In Houston, I'm John Herder. Tuesday, 25th July. Great as always to have you along, everybody. From the Experts is a virtual networking opportunity flow accelerator, helping leaders across industries connect very quickly in a brief, moderated, interactive show format, like a TED Talk with interaction. If all goes well, curiosity is sparked, new ideas accelerate action, and you may have helped yourself or somebody else solve a problem, make a connection, reaching the opportunity faster. Welcome to our third in a series of interactive shows focused on helping business leaders solve problems with AI in partnership with Hewlett Packard Enterprise. On the show today, building at scale for your successful AI journey. Folks, help me welcome guest expert Joey Zwicker. Joey is the co-founder of Pachyderm, recently acquired by HPE and built into AI at scale portfolio of products, where Joey leads the software sales, community, and portfolio strategy teams. He's also one of the creators on the board of directors of the AI Infrastructure Alliance. AYA is a nonprofit organization focused on bringing together leaders in the AI, machine learning, and ML ops space to help develop standards and interoperability across tools and practitioners that drive AI advancements forward. Joey, grateful to have you lead the practical discussion on probably the hottest topic in boardrooms today. How do we leverage AI and rapidly scale it into the business to grab market share? Am I right?
Exactly. Thanks so much for having me, John. Hey, everybody, just like John said, giving you a little bit more detail on my background, in particular, coming with you guys today while I've been a founder of multiple companies and obviously leading a lot of our AI strategy here at HPE. A lot of what I'm going to be talking about today comes from my experience working with the AI Infrastructure Alliance. And as John said, a big part about what we do is we work with hundreds of different tooling vendors, thousands of community members, data scientists, practitioners across industry and across the globe. And we talk to them and synthesize these kind of cohesive ideas around AI and AI infrastructure and how to standardize a lot of those interoperable pieces of the stack. As you all know, while AI is super hot, there is, of course, also 1,000 companies all trying to do different AI, both offering software tooling, services, infrastructure applications, and everything in between. And through our work with the AI Alliance, we basically, offer things like office hours and synthesize a lot of this information into reports and events, and bring these things together to help organizations get kind of a tool agnostic, vendor agnostic ecosystem view of how they can tackle AI challenges. So as John said, for today, a lot of what I'm going to talk you guys through is kind of the high level starting point. If you are a leader in your business, and as John said, every business is talking about, well, where can AI be meaningful and impactful to what we're trying to accomplish and how we're trying to differentiate today. Today, I'm going to talk about kind of a framework for thinking about AI problems, AI investments, how you drive AI business needs, and then start walking you guys through in a little bit more detail. What are some of those key milestones and kind of potholes that you have to consider to understand when you're going to try to scale this out? So kind of to kick things off a bit, I'll set the stage and kind of give some context. So as you know, AI is everywhere in the news today. Certainly things like ChatGPT have really kind of pushed it forward into the social sphere quite a bit. And the reality is, especially around generative AI and some of the foundation and large models that are being built today and the techniques being built around those, it really has taken a giant leap forward. But one of the things that I work with hundreds and hundreds of businesses on is it is a very, very big step to go from a cool demo with a simple application that is like, help me write my better emails, or answer customer support questions, or help me write a blog post, or do my college essay for me, right? Those types of use cases that kind of are very much in the GPT social sphere today, going from that to actually developing an enterprise business application centered around AI, that is still a big leap, and there's a big investment that organizations need to think about making to kind of drive that outcome. There are some cases where kind of just the AI in the box applications that are there today will get you started, but most of the real problems that we're looking to solve don't come with out of the box solutions. So when we are advising as part of the AI Alliance organizations, how do they tackle their problems and how do they navigate the just chaos and complexity of tackling AI outcomes, we often start by giving them kind of a framework for thinking about how they should invest and how they should think about tackling some of those needs. One thing I'll highlight here is as I go through, I've got a couple slides I'll share just as kind of reference, but I'll kind of be talking about them in the abstract. But then also, please throw questions in the chat. Please interrupt and raise your hand. I am all for kind of driving this as a joint discussion as we go. So to start off building that framework a bit, I'm going to actually break things into kind of these two sets of threes. The first set being kind of a technology framing for what does it take to invest in a stack to drive an AI outcome. And the second is what are the business needs you want to frame around kind of accomplishing that outcome and measuring success in that AI outcome you're looking for. So let me get this shared for everyone. I think everyone should be able to see that just fine. So first things first, let's talk about that technology stack. And I'm actually going to start from the bottom and work my way up. There are really three layers that people think about when investing in their technology to drive an AI outcome. There's the infrastructure layer. As we know, AI is incredibly compute intensive, both raw compute to do things like data processing, GPUs for massive scaling, and as well as, of course, storage, because AI feeds on data. You need to have kind of storage for that. And that can be both your on-prem infrastructure, hybrid cloud, or in the public cloud. So there are lots of options for how you can go about tackling those kinds of infrastructure needs. The second layer, and the one that kind of gets the most hype these days around the kind of AI ecosystem, is this AI development platform layer. And if you look at whether it's Amazon's website or HPE's or Databricks or any of them, they always break these things into kind of three key buckets for an AI workflow. There's your data management and data processing, right? Because there's a lot of pre-processing and a lot of nuance, whether it's labeling, synthetic data, a lot of nuance and complexity towards getting the right kind of data set in the right format and structure to be able to drive the right AI outcomes. There's a large part of the data side of the equation that has to happen as you're trying to build your AI use case. Then the second one, and the one that's kind of always the most popular, is training the model, right? And of course, this isn't a single time, let me go spin up a giant GPU cluster and do a single training. It's a very iterative type of approach. It's experiment. It really is the science of data science, is figuring out how to drive a model that can successfully solve your application. You know, the broader the model, the more complicated it needs to be, whereas the more narrower and focused on kind of a specific set of tasks it can do and a bunch of things it doesn't need to worry about doing, the easier it can sometimes be to kind of train and drive a specific outcome. And then, of course, once you've trained a model, you're actually not done. You have to deploy that model and run inference and actually build it into an application. And so then you finally get to this application layer, which is, well, what are your applications doing? Well, there's things like natural language processing, large language models that can both be generating text and response and driving from context. Computer vision is, of course, like a huge case, whether it's security footage, satellite footage, radiology for medical imagery, being able to identify objects and ideas in imagery. Even autonomous vehicles have a lot of use cases around this area. And then you see things like risk modeling, whether it's public health or climate risk or financial risk, loan risk assessment, asset management, economic risk. There's a whole bunch of very complicated modeling and simulation techniques around how you do things along these lines. So you get a lot of these AI applications and you need to build this whole stack together. And as you can see across the top, you know, these use cases and this infrastructure applies across industry. So if you're working in healthcare, you may have kind of much more, let's say, imagery-oriented and text-oriented types of use cases, but you're still going to need to build this stack. And so one of the first things we start to drive a focus around is understanding, here's the key components and how much emphasis you put on different components at the application, platform, and infrastructure layer will vary based on your use case and industry. But at the end of the day, you're going to need to figure out a way to solve all of these, and they're going to take a different type of investment and understanding in how to get those outcomes. The second kind of set of three that I want to drive for you guys a bit is talking about kind of how to frame those business needs to actually get results out of AI. The number of CIOs, chief data officers, directors of machine learning data science that come to us, the AI Alliance, and talk to us about, well, I've had this AI initiative for a long time, and while my data scientists are doing all kinds of really cool things, actually driving bottom line business value is still kind of a gap we're trying to close. And we keep hitting unexpected roadblocks along the way. It always feels like it's 6 months out of reach from really getting business outcomes. And so the second key idea I want to highlight here is talking about those business needs and be able to define these really clearly when you're now trying to drive an AI initiative. So across the bottom, you'll still see those same kind of ideas I was talking about. You've got your data pipelining and processing stage, you got your ML modeling and training stage, and your model deployment and monitoring and inference stage. But now when you kind of cross-hatch these with business needs, a lot of businesses often are thinking about in these three buckets. What kind of flexibility do you need, right? Do you have a very diverse set of users within your team, right? Both business analysts, data engineers, machine learning engineers, many different types of applications? Or do you end up having, for instance, like there's one area that you need AI and that's it, right? Maybe you're a bank and you're like, my fraud detection, that's my primary area. I need AI. I'm not planning on AI anywhere else. So what kind of flexibility you're looking for? What are your requirements around your environment and infrastructure? Are you able to use the public cloud and only the cloud? Do you need some cloud and some on-prem? How do you deal with things like GDPR and kind of data locality types of constraints? And then, as we said a second ago, what are the diverse types of use cases you're tackling? Because if you have many different use cases, you might actually need more flexibility in your system. The second pillar here is really around scale. There are lots of AI use cases where you can start with a relatively small amount of data, let's say pulling some tables from your data warehouse around user behavior, and build some optimization models for your marketing messaging, your customer churn and retention, and customer lifetime value predictive analytics. These are great. These don't require necessarily a lot of scale, and so it lets you scope the problem that you're trying to solve down to functionally what you're looking for. On the flip side, if you're dealing with manufacturing data, banking data, or a classic example would be like, again, this radiology and computer vision, audio, video, image data. This can be massive amount of data, lots and lots of complexity from many, many different sources. And so you have to think about scalability and how that system is not just going to work for your day zero and your day one type of success, but how is that system going to scale over time? The last pillar here is reproducibility. And what's important is that reproducibility comes in two factors. There's the, how does it help me get an outcome faster? And there's the, how does it stop me from like running into compliance and regulatory problems? So on the former, reproducibility, just like engineers use things like Git and GitHub and CI/CD for developing their code, you need reproducibility built into your AI workflows so your team can iterate faster, understand when things are going wrong, understand what types of data sets were used, and what kinds of machine learning algorithms have been working or not. That'll help them build on each other's work and drive outcomes faster. On the flip side, though, if you're working in, let's say, healthcare again, reproducibility isn't a nice to have. It is an absolute requirement that you can provably have explainable, reproducible, responsible AI algorithms that you can understand what they're doing and be able to both show internally to shareholders and to regulators, this is what my system is actually doing here. And so once again, these business needs may not apply as strongly in different use cases, but thinking about these pillars and how strongly you need to lean in towards one or the other as you're building your requirements becomes very, very important. I'm not going to go through everything on this slide, but this entire deck will be sent out for folks here available in email. But this kind of now starts to give some of the crux of those key challenges I mentioned. How do you avoid things like vendor lock-in, or how do you deal with the fact that your data is going to be siloed across different BUs and lines of business and different teams, and you don't have insight into where that data is coming from and exactly how it was derived or developed. And then some of those key mitigations that you can start to think about if that is a challenge your team has. Again, tying into number 4, Perhaps things like data versioning and lineage become very, very important features you need to think about building into your infrastructure, your platform, and your application if you have problems that look like this. So kind of in summary, one of the things I advise a lot of organizations on is how do you avoid some of these common pitfalls that you find as you're trying to go from, oh, this is a really cool like prototype of an app to actually building a production grade application. The first I always advise them on is stay focused and clearly define your success criteria. There are so many AI initiatives I see time and time again where, oh yeah, there's all this cool stuff we want to do with AI. We've got this use case and this and this and this, and we're going to try to like build a platform that can do all of them. We're going to build the term I hear a lot is an AI factory, where you've got a smorgasbord of different tools and offerings and use cases that are all there. We're going to build kind of this one unified system that can do that all. Once you have successfully driven a whole bunch of AI outcomes in your organization, yes, definitely go ahead and do that. And it's important to unify that platform. But if you're starting your AI journey, one of the things I always recommend is you have to stay focused and you want to define clear success criteria for your first couple of use cases. Because if you guys have boards the way I do, you need to invest, you need to spend, you need to drive outcomes, and then you need to say, okay, we did this. Now I'd like a bunch more money to go invest in the next thing and I kind of expand this offering. And the biggest number one way that AI initiatives fail is when they're not well scoped. They're just kind of talk about the AI dream, candidly, of what could possibly be done. And you spend a lot of money, a lot of time doing a bad job at a lot of little things, as opposed to a good job on a like one or two key use cases that prove out that value and define those business metrics. So we often will advise companies say, look, what does success for your business here look like? What would get you either that next promotion or look really good to your board, or be the big, like, what's the big blog post you would want to announce as a PR of this cool AI thing you've done? Define that criteria and then work backwards on how you're going to get there. And this goes into kind of one of the other key ideas is define a metric that is like mission critical and high value. A lot of times people want to dip their toe in the water with AI by starting with like something really simple and small. And I see a lot of organizations that will say, well, let's just see if we can get, 5% optimization out of our marketing efforts. That's great, but is that enough of a business impact that you can like provably say, wow, AI was a game changer for us? And if you're spending, hundreds of millions of dollars, 5% is amazing, right? Absolutely, sure. But that's one of the other key ideas, is not just defining a clear goal you want to outline, but also defining like, will this, if successful, be a big enough business impact that it makes a splash that I can drive the next level of investment into my AI use cases? Be prepared to invest heavily in people, software, and infrastructure. I think that is one of the things that also often gets underestimated. In particular, is this stuff is very hard and it's very different than typical and other software development and DevOps and product development type of life cycles that organizations have ever had before. And so while we usually start off seeing organizations say, well, I'm going to make my AI data science team, that's going to be part of my, let's say, data COE or my analytics like group, where you find that data science and machine learning ends up being its own kind of unique pocket of complexity. And so knowing that you're going to need to kind of give it that like investment in skill set and people to really drive these impressive outcomes, that's kind of one of the key things I always emphasize, folks. And be prepared to iterate and stay agile on it. It is a fast-moving industry. The best, large language model and algorithms today is different than it was literally 2 months ago, and different than it was literally 2 months before that, right? So it is changing rapidly. But I want to point out, this is not in conflict with number one, right? You can be agile and be able to iterate on how you're going to solve a problem and try things, and some of them won't work, and you'll need to try things again. And that's very different than not having clear goals, right? It's very easy. It's very important to have clear outcomes defined, but you're going to have to iterate very quickly to get there. It's whatever PRD your product team writes for the first AI product. I guarantee you'll look back at that and laugh when you finally get to your success, because you're like, man, were we really wrong about a lot of things? And that is very okay and very normal here. The third is, as I kind of mentioned earlier, talk about reproducibility and scalability early on. Not every use case cares about these to a great extent. And I'll give clear examples for customers I was literally working with over the last month. If you are working in a retail use case, right, trying to optimize inventory placement in your stores, reproducibility and explainability is not important. They're nice to haves at best. It would help your team develop a little bit faster. It'll help, as you have kind of team growth and changes or use cases across BUs, it'll help those be a little bit more efficient. But realistically, if you don't have clear reproducibility exactly why your model, predictive inventory management was giving the outcomes it was, it's just not going to matter that much. And so if you now take that out of scope in your goals, again, it lets you be very focused and spend a lot more time on the things that are only the things that are important. On the flip side, there are a bunch of these what we call should have types of use cases. So a good example of this is manufacturing. Predictive maintenance and manufacturing is a common example where having reproducibility there is very important, right? If you need to be able to understand why your model, said that this machine needs to be fixed or said this machine doesn't need to be, and if that turns out to be wrong, go back and figure out how can I improve this. It's not a requirement. Yes, in theory, there's maybe some legal challenges that could come up if this went egregiously bad, but it is important and it is high cost and high value to do this correctly. But it is still not an absolute requirement. Now you get into the required to have category. I was just working with a hospital system that is working on doing tumor detection in radiology imagery. Reproducibility, explainability, scale, absolute, no questions asked, fundamental requirement for this system. You absolutely cannot have an AI system anywhere near patient data and diagnostic workflows without absolute reproducibility, both internally for your patients, for your board, and for regulators as part of this. And so understanding what your use case is and where these requirements, right, those business needs I mentioned earlier, right, where those business needs are and how strong your use case needs that's the framework to start thinking about. And then if reproducibility isn't a big requirement, well, guess what? That lowers the scope of what you need to do in your data platform layer, as an example, right? On the flip side, if large distributed training on a ton of data is a big requirement, now that requires you to say, I'm going to have to invest in GPU infrastructure. So these are the kinds of trade-offs and conversations that you're having that allow you to use this framework to define how you're going to drive your outcome.
Hey, Joey, shall we go ahead and open the floor to get some feedback from the group? Are we ready?
Absolutely. So this is perfect. The last thing I'll highlight here, so kind of laying out that framework for folks, is in addition to I want to drive this conversation now forward together, I do office hours all the time for folks. And so if as part of a next step, in addition to this conversation, you want to just reach out directly to me, have a kind of open conversation around, here's my challenges, here's what I'm thinking about doing, how should I help use this framework to define what outcomes I want and how I scope and focus my problem? Always have to do that with any folks that are interested.
Awesome. Thank you. Everybody will get everybody's contact information after the show. So if you're new to the show, we roll right now into the open floor. You got a question for the expert. You're going to see us posting a couple general questions. We probably don't need them today. So just raise your hand.
Tons of questions in there already. So,
right. So, and please give your 60-second share so we can keep the discussion interactive and rolling. So with that, there were several. Marcin, would you mind asking your question to Joey?
Yeah.
Tell them who you are first.
Sure. So Marcin Mizianty, VP of Data Science at AltML. So we help traditional companies to adopt AI by delivering customized AI-powered software products that fulfill their business needs. And we believe strongly in technical excellence and engineering approach to developing and deploying ML models versus scripting. However, to make sure companies adopt and operationalize models, it requires us to not only be strong on technical side, but also on the business side, especially in ML ideation, problem definition, and product design. So my question is connected. Like I strongly agree with everything you said. Like architecture first, or at least start talking about architecture very, very early, and then all this reproducibility, building like the platform, ML ops. It's not only about deployment, but the ML development environment. But maybe my question, do you have any tips or any ideas on what comes after you define the model, you build the model, you deployed it, it's ready? User adoption, it often is where many projects are not successful because you build it, it's aligned with the business, but how do you get people to adopt it? And anything that you can share in this space?
Yeah, it's a great question. So it's going to vary a little bit by use case. When we've done with, let's say, sales and marketing optimization types of use cases, a big part of that adoption is just proving that it drives value, and we build it into a lot of our backend systems. On the flip side, with my like healthcare, radiology, or manufacturing types of use cases, user adoption there is more of a top-down methodology. So instead of trying to get individual marketing and sales functions to start using the models we built, in this case, you're saying, hey, like this is a requirement for your manufacturing facility to drive predictive maintenance on your machinery, right? And that's driven from a much more top-down model. So I think it varies use case to use case, but that was an example for one of our manufacturing customers where we actually went to their factory floor workers and validated before we even scoped the problem, like, oh yeah, machinery maintenance becomes like a fundamental problem where if machines go down unexpectedly, here's what that cost factor is. And so saying, hey, this has the potential to save you, tens of millions of dollars a year per factory. If you implement this, we already had buy-in before we even started building the model and implementing on the way down. And so I think as a startup founder, it's often advice of don't believe in if we build it, they will come. You have to validate your use case and your business outcome with that external customer and user that is going to be using that AI application as you then want before you even start scoping and building it.
Awesome. Thank you. So, hey, Joey, would you take down your presentation, please? We've got a question from Anu George. Anu, would you please go ahead?
Yeah, actually, I had two questions, Joey, and both are intertwined. One of the questions is, let's take a use case where we want to use an open source LLM, probably to have a chatbot or probably to match it against existing company data to query the database and get conversational style responses. Could you walk through what is the technology that we would need and what are the costs that one has to think about and, ballpark numbers, anything like that?
That's an amazing question. I probably have 15 active accounts today that are trying to solve exactly this use case. And I'll highlight a new, what's partly great about that is it's a fantastic starting use case for LLMs, right? Because the whole idea is, well, these language models already exist. The thing is, they don't understand the nuance, the jargon of my business. So how can I fine tune it and train it on just a small delta of value and now effectively have this internal data retrieval type of system that can, allow people to access information. If your SharePoint system looks anything like our SharePoint does, it's a nightmare to find what you're looking for, even if it exists somewhere, right? I see a lot of smiles and nods. And so having a system that can help you do that is like a great starting use case. It's also, what I will highlight with this use case is it's hard to quantify the business value impact of it. Because everybody says, oh man, it'd be really nice. But how do you derive like hours saved searching for docs? Like it's a very hard thing to like have clear success metrics around. So that's my only kind of caution I highlight for folks. Now, what you did ask is, what does it take from a tooling standpoint and cost to get there? This is one of the hardest parts with LLMs, is that today, the vast majority of them are going to require some part of specific fine tuning on the model to get you a satisfactory outcome here. To do that, yes, you base off of open source models. In fact, we've done this for some customers. We've implemented this both using Aleph Alpha's Luminous model in partnership with them, and we've implemented this using like Falcon, which is one of the better like open source models that exists today. And there's two phases to that workflow. The first and hardest phase is actually the data phase, right? Because if you want a chatbot interface for your data, the question and answer data set that you're going to train and fine that model on is actually really hard and challenging to define. And you need to kind of have a history of types of queries and data that you can drive into that to get a quick outcome. If you don't have that, you can still build it, but now you've had an entire data building phase that comes before you even get to the point of fine-tuning your model. So the expense for this is really going to be based on how well defined is your data set that you want to fine-tune on already, or do you have to start from scratch, kind of pulling that together first? And this is where kind of, whether it's the AI Alliance or HPE or other folks you might go to for solutions, this is where the advisory side of this is really important, is you're going to have to scope what that project looked like. So for one example, this customer I've referred to, it took us
just
build a
to
prototype.
ask you, like, maybe if you can also explain on where would you house the LLM? How would that connectivity work? If you can walk through that a little bit more than the database, that I understand, but I think I'm trying to understand, how do you kind of connect with the LLM? Let's say it's an open source like Falcon. So if you can walk through that,
so
that'd be very
usually
helpful.
you'd run that yourself and build that in your application. So for the customers we're doing this, they usually want to run these on-prem. They want to run this on their private data. So they'll pull that LLM, they'll do the fine-tuning workflow, which is the like hard science part. But then applicationizing it, it's building an internal application internally. So at that point, you're hosting the LLM yourself. It's not using, let's say, ChatGPT, where you're pulling out to their system. You're building on that internal, and you're running that yourself. And so to do that, you need to have the infrastructure. You need to have not a massive GPU cluster, but you need to have that infrastructure to run inference and host that model and applicationatize those systems. So that's by far the most.
Is the latency better if you put it on-prem versus cloud, or nothing like that?
That hasn't been a big factor in my mind. Again, for this type of use case, latency isn't super important. If it takes 1 second to get a response or 5 seconds to do a search and get back a response, that is not a drastic change in the user experience. On the flip side, if this was a fraud model of some kind, like that would now be like an unacceptable latency requirement. So this type of use case usually doesn't have major latency.
Got it. Thank you very much. Anybody else have a question?
I just I want to share something, if that's okay. So,
yourself.
So I'm Lexi. I'm currently working for a startup. I'm also a master's student. I used to be a pharmacist, but I do like this AI stuff now. So so from my research and what I found, there are two ways of actually doing these kind of large language models with company information. So the first one is with a vector database, and the second way is fine-tuning using transformer-based models on open source models. So with the vector database, you can now already call an API of a large language model. So for example, GPT-3 and 4, and after you load in the model, you chunk it up into, say, 1,500 tokens, and then you embed that with, say, GPT into a vector database. Now, there are different vector databases out there, and I'm still looking into different specifics. But once you have that in a vector database, you can call that with another API to get that data, and then you can use a large language model in order to summarize that information and come out with an answer to the user's query. So
that's absolutely right. There are lots of methodologies for how to solve this. Yeah, that's great, Martin. And
Anushka, do you have a question for the group?
Yes, I do. Thank you, John. Joey, thank you for hosting the show, and John. I have a question. So you mentioned that churn isn't a big problem or like a scalable problem, but in my last company that I was working for, it was a startup. That was the biggest problem, like identifying the customers as well as identifying the churn. So how are you guys helping the companies in identifying that problem?
So that's a really, I'm going to reference your question you posted in the chat too here, Anushka. Yes. You said, you talk about how churn is not a problem that's required to be scaled. So what I meant by that is the amount of data you're typically dealing with right?
Right.
Let's say doing churn analysis is usually structured data, oftentimes more like pulled in from a data warehouse as an example. So more often than not, I haven't seen teams need to, let's say, do distributed training across hundreds of GPUs to build a churn prediction type of model. This can usually be done with on like one big beefy node in a lot of cases for that training.
Okay.
And so scale, it's a now inference for this, and the scalability of needing now build this in application. Absolutely, there are scale factors there for sure, but that is a different type of scale than am I dealing with massive quantities of data and a like huge distributed training type of workflow.
So I'll give you a reference of I'll give you a reference of what problem we were trying to solve. So it was a fleet management company. So we had like a lot of data. So we were storing the data in a Google Cloud platform, right? So GCP. So like every second we would have like a data point. So we were, it was like a big data, I would say, right? So for that, it was like it had to be scaled. So giving my background, like I am a data scientist, and that's what I was working. That's how I was working there. So the biggest problem for us was data labeling and identifying the customers, and also identifying churn. So that was a big problem for us. And these days, like we have ChatGPT to do all of that data labeling, identifying customers. So I would really like to know how you would be able to help the business in that situation.
Sorry, John, did you want to say something?
Nope, up to you.
Cool. Yeah, look, there's a few different aspects to this. Whether it's when I say we help the business, if you're talking about me or HPE directly, we have software tools that help kind of develop specifically these types of workflows. So, my company Pachyderm, as an example, we integrate very nicely with a bunch of data labeling tools, even automated data labeling tools, to build out the automation part of that process, and can trigger off, let's say, whether small scale or large scale training jobs for pieces there. Candidly, one of the ways that I have found, like myself and the AI Alliance, being able to be most useful is just helping to advise folks on like which aspects of these problems make the most sense to try to tackle at a given point in time. So for the use case you're describing there, a lot of what I see in that, again, with the very basic information you gave, is there's a lot of inbound data flow. And my first question would be, do you need to do very frequent retraining of the model based on that new data flow? Or is the scale of that data flow mostly on the inference side? In other words, you might build a model once every 3 months, and now you have constant flow of data coming in that needs to have very high scale inference, very scale out horizontal inference happening for it, which is pretty different than like lots of high frequent distributed training jobs coming in kind of on the front side of that loop. And depending on which one or both of these are kind of the big areas of challenge, there's different software tooling and kind of different infrastructure that I would recommend. The cloud would work fantastic for kind of scale out inference in a lot of cases, assuming your use case like was reasonably open to using the cloud. Whereas high distributed training GPU infrastructure is super expensive on the cloud, and a lot of our customers go for an on-prem solution there instead. Does that kind of give you a context of at least how I'd approach solving a problem like that? Yeah, awesome. Great question.
Last questions. There was one about, so many tools out there, what do you actually have to think about that helps make a decision on the right tools?
Yeah, so that's kind of the exact point of this framework. Is what we saw is, if you look, I'm sure we've all seen these, what I call the like AI NASCAR slides, where it's just 150 logos of everybody, like with little boxes and overlaps and Venn diagrams of who does what tooling for right? And the exact idea of developing this framework within the AI Alliance was because giving people a decision framework that defines their outcomes first, and then you find tools to solve those problems. So I'll give a couple of classic examples. I kind of mentioned a few of them. If you are in a use case that requires reproducibility and lineage and explainability in your AI model. Now you have to use a tool that like has that built in from the ground up. So obviously I'm biased, like Pachyderm is a tool that does that, but there are lots of other tools out there that can start to solve some of these needs. On the flip side, if you don't need reproducibility and you need like real-time data flow, there are very good tools and systems like NiFi and Flink and systems in Kubeflow as an example that work really well for those types of pieces. Are you doing online inference or batch inference? Right? You know, we used the use case earlier. What are your latency requirements for your responses once you get that model into production? So these, like defining the outcome and requirements for your system, then you back into what kinds of tools you need to decide on, right? There are lots of pipelining tools out there. Some of them have data versioning built in, some of them don't, right? And you may or may not need that. And it's gonna be a lot more heavyweight to use one with data versioning if that isn't a requirement for your system. And so I'd recommend not using Pachyderm and use something like Airflow instead. There was somebody had raised their hand just a second ago. I didn't catch who that was.
Yeah, that was me, Robert Applebaum. I've got one quick question. I've worked with Fairfax Software in the fintech space, and we're IDP, looking at NLP, computer vision, traditional capture imaging. But my question is in a broader sense, when you look at these models and as fast as they're changing, to your point, 3.5 to 4 and so on, and the multitudes of models that you can look at, how do you see an organization managing, and I don't need the minutiae detail, but how do you see when you look a year, 2 years from now, how are people going to manage this, like traditional change management with compliance, regulatory, GDPR, HIPAA, you have all these things floating based on your industry. So do you see, and I haven't researched this deep, so I might be asking a question that's answerable, but maybe it isn't, is there an infrastructure platform today in change management, DevOps, whatever, that is giving the ability to where if you're using a model that's 4, and then they release 4.2 or 4.5, how do you go about bringing that in and making sure your results, are not hurt by the model changing relative to what you're trying to accomplish, which, by the way, is very specific to your business?
Absolutely. Yep. So the short answer is there's definitely no magic like change management system for all of this. But this is exactly one of those areas where the framework we talked about here actually solves that really well. So one of the bullets in the slide, I didn't go into a lot of detail that talked about like challenges and outcomes. So one example would be a containerized generic platform can go a long way towards that, because now, there's 2 challenges you highlighted. One is when a new version of something comes out, and somebody mentioned in the chat here, Llama 2 is now better than Falcon. Cool. Like if I just want to swap that out, right? What's an easy way to do that? And having a containerized system where it's literally change what model you're building into your system is like one really functional way to be able to quickly adapt to the ever-changing ecosystem. The other side of what you talk about, though, is when I make that change in, let's say, what model I'm building around, how do I do validation to make sure that that works, right? Because traditional DevOps, CI/CD has all this testing and validation workflows that built in. You can actually build that for AI too, right? And so like with our hospital teams, they have regulatory requirements and then DevOps and system requirements for if they're going to deploy a new model, it has to go through months of like testing and validation before that can kind of get rolled out. And so talking to Anushka's question earlier, sometimes you're rolling out a new model every single day or every other day. And sometimes your new model frequency is a 3 or 6 month cycle, depending on that use case. And so depending on which of these buckets you're in, you're going to have to build out those functional systems. And this is why automation, flexibility, portability, as requirements of your system may or may not be important. And in the case that they are, you have to think about building that from the ground up, right? You can't add data lineage and automation systems after the fact to your system when you realize, oh, shoot, now a new model came out and I don't know what to do with this. You're going to be kind of burning it all down and starting again, and nobody wants to go to that kind of pain. So you need to understand.
Pretty good lifting today, then. What you guys are doing is some pretty heavy lifting today. Just getting this kind of framed up. It's heavy lifting,
and it's building a system that has that flexibility built in. That agility I mentioned in critical point number 2, what you just described is that type of agility. And it's building enough agility, but not too much. You don't want to overdo it if your use case doesn't require it. That's my big guidance there.
Thank you.
Thanks. Last word. Joey, I think that about covers. I think that
restart anytime. These are amazing questions, folks.
So thank you very much, Joey. Folks, how was the expert talk and discussion today? As you can see, the survey's up. Please take a moment to go ahead and finish that. It's very important for us to continue to get better, make this a good experience for you. Today's post show notes will hit your mailbox very soon with the slide deck that you saw, everybody's contact information so that we can follow up, as well as the chat file, right? And other information that you need. Next up from the experts, Solving Problems with AI continues on August 15th as NVIDIA Manager of Global Alliances, Sri Vijayaraghavan, explores AI from pilot to production, why enterprises need a full stack platform. Well, with over 2,300 members, 20,000 followers across 25 industries, the FTE network is growing fast thanks to you and our sponsors. So please check out our library of expert content and never miss a show by subscribing to our YouTube, Apple, Spotify channels. Yeah, and be sure and register for more shows just like this one on our website at fte.network. Folks, we're out of time. Thanks once again, Joey, and all of you from the experts on the FTE show. Take care.
Thanks for having me.